In this question, a farmer wishes to enclose a rectangular pen in the corner of her farmyard for her miniature goats. There is an existing fence along two of the sides, like so. If she has 100 feet of fencing for these other two sides, what are the dimensions of the largest pen she can enclose? So before we get started here, we already know a little bit about the perimeter. We know these two sides must add up to 100, so if one side is x, the other side must be 100 minus x. Now on the right-hand side here, we're given the task of dragging statements from the toolbox area and placing them in the right order in the assemble solution area. So, first let's start by coming up with a function for the area. So we'll define our area by letting y be the area. Next, because we know the two dimensions of a rectangular plot, we know that the area will be x all multiplied by 100 minus x. From here, we will distribute the x and the 100 and the x with the negative x, which gives us the next tile. It's already in the right order. 100x minus x squared. From here, we'll change the order so that we're in descending order of powers, like so. So now we have y is equal to negative x squared plus 100x. And now we're ready to start completing the square. Notice that we have a leading coefficient of negative 1, so we'll factor out that negative 1 from our first two terms, and this tile is already in the right spot. Next, we'll take our b term, in this case the negative 100. We will divide it in half, which gives us negative 50. And then if we square it, we have plus 2500 and minus 2500. So that tile is also in the right spot. The negative 2500 now needs to be multiplied by the leading coefficient, negative 1, to bring it outside of the brackets. And when we do so, we're left with this tile. And now we need to simplify. Negative 1 times negative 2500 gives us positive 2500. And when we complete the square, x squared minus 100x plus 2500 is the same as x minus 50 all squared. From here, we're now able to answer our question. We know that we have a maximum area that she can enclose of 2500 feet, and that occurs when x is equal to 50. So we can drag that tile into place. And because we know that the dimension for x is 50, we can then substitute it into our other function, 100 minus x, or 100 minus 50, to determine that the other dimension indeed is also 50 feet. So the pen is 50 feet by 50 feet with a maximum area of 2500 feet. Finally, let's check our solution, and we are correct.